This video is for Chemistry in the Earth System, Unit 3.5, Chemical Formulas. Today's essential question is, how are the formulas for ionic compounds written? Our first main idea, chemical symbols and subscripts. A chemical formula tells what elements make up a compound and how many ions or atoms of each element are present. An ionic compound consists of cations and anions held together by the attraction between their opposite charges. The chemical formula of an ionic compound consists of two pieces of information. The first is a chemical symbol. A chemical symbol uses 1 up to 3 letters of the alphabet to represent an element, and each element has its own symbol, as approved by the International Union of Pure and Applied Chemistry. In an ionic compound, the symbol for the positively charged ion always appears to the left side of the chemical formula. The symbol for the negatively charged ion always appears on the right. The negative and positive ions in neutral ionic compounds are always electrically balanced. For example, consider the formula for calcium fluoride. This ionic compound contains the elements calcium and fluorine. An ion of fluorine is called fluoride. In its chemical formula, the symbol for calcium, which is Ca, will appear on the left because the calcium ion is positively charged. The symbol for fluorine, F, will appear on the right since the fluoride ion is negatively charged. The second piece of information included in a chemical formula is the subscript, which follows each ion's chemical symbol. The subscript indicates the number of ions of each element present in each formula unit of the ionic compound. Because ionic compounds are composed of ions, they do not form discrete molecules. The ions in a sample of the compound are ordered in a repeating pattern called a crystal lattice, not a molecule. The smallest ratio of ions in any sample of this ionic compound is known as the formula unit. For example, the compound calcium fluoride consists of one calcium ion bonded to 2 fluorine ions. Therefore, the formula for calcium fluoride is written as CaF2 on the bottom right hand of your screen here. Note that the numeral 1 is not written as a subscript after the symbol Ca. This is because when an ionic compound contains only one ion of a certain element, no subscript follows the ion's chemical symbol. Let's consider another example. The ionic formula for common table salt, aka sodium chloride, is NaCl, shown on the bottom right of your screen here. Since no subscripts follow the symbols for sodium, Na, or chlorine, Cl, the formula shows that only one ion of sodium is bonded to only one ion of chlorine. Our next main idea, determining subscripts. How are the subscripts in the formula for an ionic compound determined? Remember, all ionic compounds are electrically balanced. The total positive charge of the cations in a formula unit is equal to the total negative charge of the anions in the formula unit. Consider the ionic compound calcium chloride, shown on your screen here. The calcium ion has a charge of 2+, and so we represent that as Ca and a superscripted 2+. The chloride ion has a charge of -1. For the charges in calcium chloride to balance, the compound must contain 2 chloride ions for every 1 calcium ion. This means that a balanced chemical formula for calcium fluoride would be written as CaCl2. However, when writing chemical compounds, We always use the simplified ratios for ions used. The simplest way to write the ratio for calcium to chloride is 1 to 2, which again is why we write the formula CaCl2. This ratio is due to calcium having 2 valence electrons. Chlorine can only receive 1 electron per atom. Therefore, it takes 2 chlorine atoms to bond to 1 calcium atom. Our next main idea, subscripts for transition metal cations. The process is a little trickier for cations formed by transition metals, such as copper, Cu, iron, Fe, cobalt, Co, chromium, Cr, and mercury, Hg. Many transition metals can have multiple oxidation numbers and therefore can have more than one correct formula. Thus, most transition metals can form more than one ion. For example, copper can form compounds with either copper 1 ions, which is copper with a charge of positive 1, or copper 2 ions, which is copper with a positive 2 charge. To write a formula with a transition metal, the charge of the cation is needed in the name, or in the formula rather. The name of the compound will contain a Roman numeral in parentheses to indicate the charge, immediately following the transition metal's name, as is shown on the screen here. Using the correct charge, the same steps are used to write the formula that will have a ratio of cations to anions that results in a neutral compound. In the case of copper 2 chloride, the copper 2 ion has a charge of 2+, and the chloride ion has a charge of 1-. For the charges to balance, the compound must contain 1 copper 2 ion for every 2 chloride ions. This 1 to 2 ratio is used to write the formula CuCl2. Polyatomic ions. Many ions consist of single atoms that have lost or gained electrons. Ions may also form, however, when a group of 2 or more bonded atoms loses or gains an electron and thus carries a charge. Such groups of atoms are called polyatomic ions. Now, the atoms within the polyatomic ion are covalently bonded. Their bonds consist of pairs of shared valence electrons. However, the total number of electrons in the polyatomic ion differs from the total number of its protons. This is true because the polyatomic ion has gained or lost at least 1 valence electron. The electrons may have been transferred to or from another atom or group of atoms. The result is that the polyatomic ion possesses an overall positive or negative charge. At this point, you should be able to generate a full and appropriate response to today's essential question. How are the formulas for ionic compounds written?